Okay. Now talking about the diamond. Diamond is another allotrope of carbon that we are discussing. First of all, let me explain you one more time that what is an allotrope. The existence of an element. An element. We are talking about an element, not a compound, not a substance. An element. In nature or in our crust, due and have means the nature of, or we can say that existence of an element in different forms in nature due to different arrangements of their atoms. For example, in graphite, carbon-carbon atoms are arranged in hexagonal structures. Okay, and in diamond, the and in diamonds, tetrahedral structure. We talk about this one. Okay, so in diamond, the carbon atoms are arranged in tetrahedral structure. Okay, so they are arranged in tetrahedral structures. So talking about this one, that one is good conductor of electricity because in this alternate double bonds are formed, and due to alternate double bonds, delocalization of electron is possible. Okay, delocalization of electron is possible. But here, if we talk about this one, there is every carbon atom is bonded with 4 other carbon atom, no double bond, no alternate double bond. So diamond is a bad conductor of electricity. But
So
talking
in
yes,
graphite, there is no double bond and they lose electrons. So that's why they are good conductors of electricity.
there is an alternate double bond. Do I have taught this one to you or not?
So you just gave the idea about it.
So let me explain you this. There is double bond, alternate double bond is formed. That is called delocalization of electrons. Okay, let me show you in NCERT if it is there. So let me wait a minute. In graphite, each carbon atom is bonded with 3 other carbon atoms, but there is a alternate double bond is formed in order to attain this stability. Okay, here it is not shown in the figure. Let it be, but I'm going to explain you. This is an advanced version. Okay, so let me show you. Actually, you see here that this is one layer of graphite. Okay, and each carbon atom is bonded with 3 other carbon atoms. So can you imagine that how this carbon atom be stable with 7 electrons? Let me show you what I'm saying. Here, this is a carbon atoms. Okay. So if you see here that each carbon atom is bonded with 3 other carbon atoms. Okay. You can check here that I'm just removing this one. So here you can check that each carbon atom is bonded with 3 other carbon. You can check here. You see here this carbon is bonded with 2. No, it is also bonded with a carbon here. It is also bonded with another carbon here. So you can check that this is fully bonded. Okay, they are not going to bond with some other. They are not going to bond. Like this carbon is fully bonded. Like this carbon is fully bonded. This carbon is fully bonded. So each carbon is bonded with 3 other carbon atoms. Okay. Okay.
Yes.
But and when a bond is formed between the 2 carbon atoms, so let's suppose I'm just going to give you example of this one. So let's suppose this, there are the 4 electrons in the outermost shell of carbon. So 1, 2, 3, 4. 1, 2, 3, 4. Okay. So there is a single bond between this. This can make a single bond with this carbon atoms. Okay. And this can make bond with another carbon atoms. Okay. Let me show you here. Let me show you here with different color. That, for example, let's talk about this one. One carbon atom is here, one carbon atom is here, one carbon atom is here. And the sharing electrons of the other one. Sharing electron of this carbon atom, let's suppose this carbon atom is sharing electron with this green one. With this carbon atom is also sharing. And this carbon atom is also sharing its electrons. So that's why 6 electrons are there. Okay, and carbon has 4 electron in its outermost shell. So one unbounded electrons is also present here. One unbounded electron is also present here. Okay, this is a green, 1, 2, 3 of this one, and this is unbounded. This white color is unbounded, which is not participating in the bond. So will this carbon be stable with this 7 electrons? No. 1, 2, 3, 4, 5, 6, 7. No. It wants 8 electron in its outermost shell. So what is going to happen here is that this carbon atoms, this is going to have 1 free electrons everywhere. Okay. They
So
are going to have,
alternate bondings will be there.
yeah, there will be alternate double bonds will be formed. Okay. So in order to attain stability, they will make alternate double bond. Okay. So let me show you that there is a bond. If this is making bond, then this electron is busy with this one. No bond will be formed here. Then this electron bond will be formed here. This bond is formed here. This bond is formed here. This bond will be formed here. This bond will be formed here. Okay. This bond will be formed here. Similarly, okay. So if we talk about this one, that alternate double bonds are formed between 2 carbon atoms, and every carbon is now making 4 bonds. For example, if you are choosing this carbon, so okay, so here if it is, and you have this one also, so this carbon is making 4 bonds. 1, 2, 3, and 4. Everyone is making 4. Okay, 1, 2, and 3. This carbon, if I talk about 1, 2, 3, and this will also make a bond with this another carbon atom right here. So every carbon atom make alternate double bond. After this one, after some time, this bond where it is single, this bond will shift here. This bond will shift here. Means where it is double bond, it will be shifted. It will become single, and where it is single, it will become double. So this is shifting of bonds, double bonds taking place. Okay, and why does it shift? We will learn in the higher classes. So we will simply say that here the D, and this process is called delocalization. For example, if we have this carbon atom, single bond, then double bond, then single bond, then double bond. So if there is a repetition of single double bond, then after some time, means in 1 second, millions of times it will happens that it will become double, then single, then double, then single. Where it is single, it will become double. Where double, it becomes single. So this is called delocalization, and because of this delocalization, this vibration of electron clouds or bond from one carbon to this one and again back to this one. So this is called delocalization of electron, and graphite is able to conduct electricity just because of this delocalization is taking place. Okay, understood?
Yes, sir.
Because carbon cannot remain stable with 7 electrons in its outermost shell. It must make alternate double bonds. Okay.
Yes, sir. So it can have a question that with seven electrons, it cannot make
No, it
stability.
will not be asked. No, it will not be asked. It will be asked that why graphite is able to conduct electricity. Please note it down. This is a statement I have written here. In graphite, each carbon atom is bonded with 3 other carbon atoms, leaving an electron free. These free electrons results in alternate double bond. As a result, delocalization of electron is possible. This makes graphite good conductor of electricity. Note it down. Done?
No, sir, 1 minute. Done, sir.
Okay. Next one is why diamond is hard and bad conductor of electricity. So let me explain you that what is special about tetrahedral structures. First of all, for example, if a carbon need to make bond with four other carbon atom, it can make bond with this type prototype like this. All the atoms are in plane, in a square plane. Okay, like this. And it can make bond in tetrahedral structures. Okay, like this, which is like this. Okay, like this, like a tripod. Or we can make it like this way. Okay, what is special in this structure? The specialty in this structure is that in this structure, every bond angle is same. Means this is the bond angle between this carbon atoms and this carbon atom is same. This,
Sir, it's like
yes,
a triangular shaped one.
it is the shape of like tripod, camera tripod. Okay,
Yes.
109.5 degree. Yes, I'm going to show you this the shape of this one also. Okay, and but what is the difference between here and here is that if you apply the force on this carbon from in this direction, then the maximum force will be exerted by this carbon. If you apply the force in this direction, then the maximum force will be exerted on this carbon. If you apply the force on this direction, then the maximum force will be exerted on this direction, on this carbon. So there is not an equal distribution of forces taking place. Not every carbon means if you are applying force in any direction, there is one or two carbon will be there, which will be experiencing the highest force. Other carbons will not feel the means will not experience that force. So this square planar structure, square planar structures is not so strong. Okay, and here moreover the bond angle between here and here in this two is 90, and here it is 180 degree in between two. So two bonds are of 180 and two bonds are of 90 degree. So this is also not fair. Why the two bonds? So they should arrange themselves in such a manner that every bond angle should be same. So they arrange themselves. And how they arrange themselves? Let me show you. Okay, this is the structure of diamond. Sorry, tetrahedral structure, and this is a very common structure. Okay, and this is like this. If you apply the force from in this direction, then the equal force will be distributed here, here, and here. Okay, even if you apply the force in this direction, in this direction, then the equal force will be distributed on this one, okay, and in this one, all the direction. It is going to have symmetrical geometry. From everywhere it is same. Let me show you how it is same. It is going to same from everywhere in all the direction. So let I rotate it like this way. Okay, so it is going to have same shape, means equal. If you apply the force here from this direction, then the force will be equally distributed on this and this and this. Okay, if I rotate it further like this, so it is going to have same bond angle everywhere. Okay, so if you apply the force from here, if you apply the force from here, if you apply the force from here, the force will be equally distributed, and the bond angle is also same. The bond angle between this and this is also 109.5 degree. 109.5 degree. It is also 109.5 degree. Okay, and this is also the bond angle between this and this also 109.5 degree. And the bond angle between this one, and this one is also same. So every bond between every atoms is same. Every bond angle is same. So there is an equal distribution of force take place. So that's why diamond is very hard. Okay, because when you apply the force, that is distributed in all equal bonds equally, and the bond becomes more stable. Okay, understood?
Yes, sir.
So you need to keep in mind here that you need to write the that why diamond is hard. So the reason is in diamonds, each carbon atom is bonded with, and why it is not able to conduct electricity? Simple reason, because in diamonds, each carbon atom is bonded with four other carbon atoms, and there is no unbounded or free electrons is there. Okay, so if there is no free electrons, no electricity will be conducted. Okay, so in diamonds, each carbon atom is bonded with four other carbon atoms, leaving no electron free, which make diamond good conductor of, bad conductor of electricity. Okay, and in diamonds, each carbon atom is arranged in tetrahedral structures, in which all carbon-carbon bond angle is same or equal, same, equal, that is 109.5 degree. And as a result, equal force is distributed along all the sides, which make it hard, naturally occurring substance. So please note it down.
Yes, sir.
Done?
Yes. So what is after as result?
What as a result? As a result, equal force is distributed. Equal force is distributed along all the bonds, which make it hard, naturally occurring substance.
Done, sir.
Okay. Okay. Next is organic compounds. Okay. Now talking about the organic compounds, that what are organic compounds? Okay, we have studied about the carbons and their allotropes. Now we should be moving towards the organic compounds. So what are organic compounds? Organic compounds are the compounds. First, earlier assumption was there that organic compounds was believed that organic compounds are those compounds that are being synthesized inside a living organism or a plant. Okay, but not in naturally like in the earth crust, like in the atmosphere. No, organic compounds are those compounds that are synthesized in the living organism. Okay, like plants, animal. So this was, but and there was a theory called vital force theory. There was a theory, we called it vital force theory, which was given by Burgess in 1815, who said that it is impossible to create organic compound artificially in the laboratory. Okay, so why he's saying, because he said that it is impossible to create an we can say that organic compound which is synthesized inside a living organism artificially. Means we cannot synthesize a protein, we cannot synthesize carbohydrate, we cannot synthesize urea, okay, artificially in the lab. Because he said that according to him that a mysterious force, a natural force, some means a force which we can't produce artificially, okay, is being required to produce. Okay, and this mysterious force is only given by God. Okay, so we cannot produce it artificially. So what does it say? He say that that earlier attempts for this one, that a vital force is he called it mysterious force, is required to prepare organic compound which is impossible to create artificially. Means we cannot create organic compound artificially. But a German scientist named Friedrich Hohler, what he does actually, he does, okay, he made an artificial compound. Sorry, he made an organic compound, that is urea, that we call it urea. Okay, are you getting my point?
Yes, sir.
From an inorganic substance, okay, and that was ammonium cyanide, NH4CNO. So when he heat ammonium cyanide, okay, in the lab, then it get converted into NH2C double bond O NH2, and this is urea. Okay, and what is this? This is ammonium cyanide is, tell me, is an inorganic compound. This is ammonium cyanide, which is an inorganic compound.
Sir,
Ammonium,
ammonia is organic compound, right?
ammonia, ammonia we can prepare it, means it is a natural gas, NH3. It is
Yes, sir,
not an
it's
organic.
organic compound, right?
No, it is not an organic compound.
Okay, sir.
Okay, ammonium. So ammonium cyanide. We are talking about ammonium cyanide. Okay, so ammonium cyanide is NH4CN. He get this ammonium cyanide? He reacts ammonium chloride with potassium cyanide, KCNO. KCNO. Okay, then he got ammonium cyanide, NH4CNO, NH4CNO, ammonium cyanide, and then when he further heated continuously, then on heating, it get converted into urea, that is NH2C double bond O NH2.
Sir, he got it chemically, right?
Yeah, in the lab. So this is an inorganic ammonium cyanide, which is an inorganic compound. Inorganic means that is not produced inside the living organism. This is found in the earth crust or somewhere in the means you can prepare it artificially in the lab. Okay, and
Sir,
this one is the organic, which is generally found in the living organism. But here, organic compound. This is organic compound. You understood?
sir, so the previous scientist assumption was wrong or it was correct?
No, no, it was wrong. He proved Burgess wrong. Burgess theory that was given by vital force theory, he proved it that wrong. Okay. Okay.
Yes.
So what was the new definition for the organic compound? Because previously it was that organic compound are those compounds that are synthesized or produced inside or found inside a living organism like plants and animals. But now we can prepare it artificially. There are so many compounds after the urea. Urea was the first organic compound which was prepared artificially from inorganic compound. Okay, but later glucose, carbohydrate, proteins, and there are so many amino acids and so many compounds that was prepared artificially in the lab, which are the organic compounds and which was prepared from inorganic substance like carbon dioxide, water, with the help of carbon dioxide, water, methane gas. Okay, there are so many other gases. So we prepare it with the help of them. Okay. So now talking about this one, that what does Friedrich Kohler does? Friedrich Kohler produce a first inorganic compound, sorry, organic compound, that is urea, from inorganic substance, that is ammonium cyanide. Okay. And he proved vital force theory, which was given by Burgess wrong. Okay. Now moving to the further here. Now what is the modern definition of organic compound? Modern definition of organic compound is that organic compounds are the compounds of carbon and hydrogen. Carbon and hydrogen. Okay. And it may contain carbon, hydrogen, or it may also contain, it is not only carbon and hydrogen, it may also contain nitrogen. For example, it may also contain some nitrogen in the compound. Okay, like we have NH2, C double bond O, NH2. So here is carbon and hydrogen, but we also have nitrogen here. So it may also contain nitrogen. It may also contain phosphorus. It may sulfur, etc. And few metals like sodium. It may also contain few metals like sodium. Okay. So what is the modern definition? That organic compounds are the compounds of carbon and hydrogens and their derivatives. Derivatives also. Derivative, what you need to understand, what is derivatives? For example, if we are going to have alcohol, okay, that is C2H5OH. So this is an organic compound and it is a derivative of CH2 double bond CH2. So when you add water to it, then it get converted into CH2. One H of water will be added to here and another H of what sorry, another OH. Water can be written as HOH. So one H is added here. When this bond break, the valency of one carbon and one carbon which will be freed. Okay, so one hydrogen from this one comes here and this OH group attached here. Okay, OH group. So it will become CH3, then CH2OH, and togetherly you can write C2H5OH. So this is ethanol. So ethanol is a derivative of this one. Means ethanol has been derived from ethyne. Okay. So and their derivatives. So you know so we can say that this is a hydrocarbons and its derivative ethanol will be considered as also as an organic compound.
Sir, what is ethanol and ethanol?
Ethanol, you don't know? Ethanol is a compound that we're going to study. Okay, ethanol is like ethanol, ethanoic acid. This is a compound that we're going to. This is a type of alcohol. Like
Sir,
we have different.
ethanol means only a single carbon will be there, right?
It means two carbons compound. It matlab METH, meth means one carbon compound. METH means ethanol means two carbon compound. We're going to discuss this one when we'll learn IUPAC a little bit IUPAC. Then we'll be going to discuss this one. Okay.
Yes, sir.
So it's derivatives. So ethanol is a derivative of ethyne. And why it is I'm saying this is ethyne, why I'm talking about this ethanol, we will learn this one. Okay, don't worry about it. So please note down the definitions of organic compound. That what was the definition of organic compounds? So note it down. Write color and this write down this reaction. It is ammonium sided or organic compound. He proved vital to theory wrong by preparing organic compound urea from inorganic compounds. Please note it down.
Sir, so I should not write the earlier scientist's name.
No, that's not important.
Okay, sir.
Note it down. Note it fast.
Yes, sir.
Done.
Yes, sir.
So let's move further. Now talking about the functional group. Okay. Now we're just going to study the how to write the names of a compound and why ethanol name is ethanol, why this simple carbon is going to have ethene as a name. So if it is CH2 double bond CH2, it is ethene, ethene. If it is CH3, CH3, it is ethane. So why we are going to have different names of different compounds? We're going to study that one. Okay. First of all, we're going to discuss that what is. Oh, first of all, you need to write the definition of this organic compounds also. Write down the definition organic compound that these are the compounds of carbons and hydrogens and their derivatives. They may also contain nitrogens, phosphorus, sulfur, and few metals like sodium, etc. Done?
Sir, the last one. Done, sir.
Okay. Now talking about the next one is what is functional group? If I talk about functional group, the functional groups are an atom, they can be an atom or a group of atoms. For example, if I'm having a hydrocarbon, okay, like for example, this is an hydrocarbon, okay, chain. Let's suppose this is a hydrocarbon chain. And if I remove one hydrogen from anywhere, okay, every carbon atom is making four bonds. Okay, maximum bonds made by a single carbon atoms can be 4. Okay, so let's suppose if it is breaking single bond. If it is breaking a bond, we just remove one hydrogen from here, it broke, and we just attached OH group to it, OH group to it. Okay, or then this OH group, because of this OH group, this whole hydrocarbon will start showing the property of alcohol because of this OH group is attached. We remove the hydrogen from here, it will start showing the property of alcohols. Similarly, if we have this same hydrocarbons, and if we are attaching, okay, like we are attaching COH group to it, then it will start showing the property of acetic acid, or we can carboxylic acid. Okay, so there can be an atom or a group of atom which when attached to a hydrocarbon chain, then it starts showing the property. Of, okay, means the whole hydrocarbon chain starts showing the property of that group of atoms. Okay, according to this group of atoms. So this group of atoms are considered to be as functional group. What we call them? Functional. There can be so many types of functional group, like we have aldehyde, like we have NO2, like we have chlorine, bromine, iodine. Okay, so what is actually functional group? We can say that it can be an atom like chlorine, bromine, and okay, like for example, if I remove this one, and if I remove this hydrogen from here, and if I place chlorine here, okay, then it will start showing the property of this according to this functional group. Okay, so if I'm talking about that an atom or a group of atom when attached to an hydrocarbon chain, okay, that determines or that help in determining the physical as well as chemical properties of that whole hydrocarbon. What I'm talking about, let me explain you one more time. An atom or a group of atom like OH, like CHO, like COOH, an atom like this, chlorine, bromine, iodine. Okay, an atom or a group of atom attached to an hydrocarbon chain. We are just attaching it to an hydrocarbon chain. And because of that attachment, the whole hydrocarbon chain starts showing the property. Its physical properties change, his chemical property change, and it starts showing the property according to that group of atom or the atom attached to it. Okay, so we called it functional group. You understood?
Yes, sir.
So what is functional group? An atom or a group of atom attached to an hydrocarbon chain that determine the physical and chemical properties of hydrocarbon chain is called functional group. Note it down.
Sir,
Yes.
in school, they asked me a question, but I could not answer for them.
Okay. Ask.
Sir, they asked that whether IUPAC gives the chemical name or they are decided by the scientist. I got confused.
No, actually, they are not decided by. There are some rules, sets of rules. Okay, that IUPAC set. Okay, that, for example, if we have 5 carbon chain, and if it is going to give you, means, for example, if we discovered some element, okay, new element, new compound, and we check it that how many carbon atoms it is going to have, what functional group it is going to have. So then we can write its name, because there are more than 3 millions of compounds has been formed of carbon, and we cannot write the name of, we cannot give any name, means we cannot give any name to anyone, any compound. Like, for example, if we discovered in India, so a scientist, group of scientists start saying, no, this will be the name of this compound. The other group of scientists start saying that, no, this will be, this is, it is discovered in French, so we will going to give the name in French. No. A compound which is popular, which is more popular, which is more frequently used, can have common name. Okay, it can have common name. For example, ethanoic acid has a common name of acetic acid. Okay, methanoic acid has a name of formic acid, but methanoic acid, it is not a sim. If we're talking about ethanoic acid, so it represent that, it is representing that eth means 2 carbon, N means single bond between carbon atom, oic acid means COOH group is attached. So lot of information is being, you can discover from it. So what was your question, that it is the chemical name, it gives the chemical name, or
The
what,
scientist name.
or scientists give this name to it?
Yes, sir.
No, it is a chemical name. Scientist means, it is IUPAC is a means, we can say that it is a sanstha. What we call it, sanstha in English? Means it is an organization. Okay, where they have this organization that is called IUPAC, is International Union for Pure and Applied Chemistry. Okay, so this international union is a organizations that has set some rules for writing the chemical name of a compound. So whether it is discovered anywhere in the world, or if it is bought from somewhere in the universe back to the earth, then the name of that compound will be written according to the rules set by this IUPAC. Okay. So
Yes, sir.
any scientist cannot have name of a compound according to him. It gives the chemical name. Okay. Are you
Yes, sir.
understood?
Yes, sir.
Does your teacher tell you the answer?
Yes, sir. She told, but I didn't get it proper.
Okay. So note it down that what is functional group? Functional group is an atom or a group of atom attached to an hydrocarbon chain. We will learn this when you learn the rules of how to write the IUPAC name of a compound. Then you will learn that what should be the appropriate answer according to you. You need to give it to your teacher. Don't worry about it. In the next class, you will learn how to write the IUPAC name. Note it fast. Functional group, an atom or a group of atom attached to an hydrocarbon chain an atom or a group of atom attached to an hydrocarbon chain that determines the physical and chemical properties of hydrocarbon is called functional group. Done?
No, sir. Drawing the structure.
The structures are not so important. Have you written the definition?
Yes,
So
sir.
because the time is not so much, okay, so we cannot study the how to write the IUPAC name. So note it down that In the next class, I will teach you after the functional group. Okay. And now we're going to jump to the next topic. Okay. So I will teach you that write down whenever I will ask you in the next class that what I need to do or what we have learned in the previous class. So you need to tell me, sir, we have written the functional group and you need to teach me IUPAC. Okay.
Yes, sir.
Okay. So now talking about the next one is we are talking about saturated and unsaturated hydrocarbons. Saturated and unsaturated hydrocarbons. So if I talk about what are saturated hydrocarbons and what are unsaturated hydrocarbons, okay. Saturated and unsaturated hydrocarbon. Saturated and unsaturated hydrocarbons. Hydrocarbons. So you know that a carbon has 4 electrons in an outermost shell and it need to make 4 extra bonds. Okay. So 4 bonds means it wants 8 electrons in its outermost shell. Okay. So if I'm talking about this one, if I'm talking about this one, that for example, if you have some carbon atoms, and in those carbon atoms, if the bond is formed, okay. For example, uh, means a carbon atom has utilized its full combining capacity, means maximum 4 single bond has been made. Okay. For example, here, if it is this is hydrogen here, and this is another carbon. Okay. So here each carbon atoms has utilized its full combining capacity. Okay, it has makes 4 single bonds. So it is considered to be a saturated hydrocarbons. It is considered to be a saturated hydrocarbon. Okay, means no more things can be added to it further. Okay, for example, if you want a reaction of this one with this chlorine gas, okay, so you don't think that one of the chlorine atoms will means it will not happen like this. It will not happen like this. Okay, means one of the extra chlorine can be added to this one. No, it will not happen like this. Okay, a carbon cannot make 5 bonds. Okay, 1, 2, 3, 4, 5. No. Okay, so if this it is what it means, if it wants to react with this chlorine, okay, so what would happen? It will remove one of its hydrogen atoms. Let's suppose this hydrogen atom will remove from here. Okay, and one chlorine atom will combine here, and this one hydrogen atoms and remaining one chlorine atom will mix together and will form HCl. So since this hydrocarbon has utilized its full combining capacity, so there is a substitution reaction will take place. Substitution means one need to be replaced to come, means if something we need to add, so something we need to replace from it here, there. Okay. Okay.
Yes, sir.
Understood. But what is
Yes, sir.
unsaturated hydrocarbons? Unsaturated means there is a double or triple bonds. Okay. So for example, if I'm having this carbon atom, this is making 2 bonds here and one with this carbon. Okay. And one electron of each of them is free. So it is making 1, 2, 3, 7, 2, 2, 4, 2, 6, and 1, 7. So 7 is not stable. So in order to make a stable, they will make double bond here. They will make double bond here. Okay. So you see that now it is stable, but not so much stable. Okay. But it is not, we will say that this is unsaturated hydrocarbon. Why? Because if we add hydrogen to it, let's suppose if we add hydrogen to it in the presence of nickel, palladium, and platinum, hydrogen gas, we pass the hydrogen gas pass through it, then this bond will break, and the 2 new valencies of each carbon will be separated out. Okay, so this one and this one, and one of the hydrogen atoms from this one, because this is hydrogen atoms, they are combining together like this way. So they will come here and will make bonds like this. Okay, so one hydrogen atom, so this bond will break. Now this carbon has utilized its full combining capacity. So if there is double or triple bond between 2 carbon atoms, then we will simply say that it is considered to be as unsaturated hydrocarbons, and carbon has not utilized for its full combining capacity. Okay, understood?
Yes, sir.
Understood. So will you able to write the definition of saturated and unsaturated hydrocarbon?
Yes, sir.
Saturated means carbon, note it down, carbon atoms are attached with single bond, and each carbon atom has utilized its full combining capacity. Okay, understood?
Yes, sir.
Next, unsaturated hydrocarbons. Unsaturated hydrocarbons. You simply say that compounds of hydrocarbons in which there is double or triple bond between any two carbon atoms. There is double and triple or triple. There is double or triple bond between any two carbon atoms, and each carbon has not utilized its full combining capacity. Okay, understood, Lana? Understood?
Yes, sir.
Zainab, we're just going to have an oral test of yours of metallurgy. Okay, we'll announce the date soon, but we're going to have an oral test. Okay, so prepare metals and non-metal chapters. So I think we have studied the whole metals and non-metal chapter thoroughly. So metals and non-metal chapter we're going to have an oral test of yours, and we'll tell you when. It might be on Friday, maybe of 20 or 30 minutes. So you need to prepare that one, and your marks will be given according to that one. Okay.
Yes, sir.